Okay, here we want to look at infinite limits. We want to look at infinite limits, limits that go to infinity. So the first thing we want to see is we want to look at the limit of the function x minus 3 divided by x minus 2 as we approach 2 from the right side. Remember, this plus sign means from the right side. So anytime we have this type of function, we should know if we were to put 2 in, directly in as we would approach it, or using direct substitution, it would be -1/0, which would be undefined. So that's kind of a telltale sign on what we should do. But either way, let's look at this one. So we know that to find out, we first need to find our vertical asymptote. I'm coming over on my scratch paper. Remember, when we find the vertical asymptote, we set our denominator equal to 0. So x minus 2 is equal to 0, and that's an easy solve, easy solution. X is equal to 2, that's the vertical asymptote. So what we want to do here, we want to graph x is equal to 2. Right here, this is x is equal to 2. This is our vertical asymptote. Now, if we remember, we can never cross this vertical asymptote. All right. We'll know that we've done something wrong if we cross that vertical asymptote. All right. I'm also going to make it a little bit longer here. All right. So now, what we do here, remember, by the rules for the limits, we're approaching 2 from the right side. So we want to get closer and closer and closer to 2. But remember, we can't plug 2 in using direct substitution because it would give us an undefined, problem. All right, so let's look at this one. So the first thing, let's just plug in a 4. I'm going to move back this way. We can plug in a 4. And let's move toward 2. And plug in a 3. Let's get a little bit closer. We could plug in a 2.5. And let's get even closer. Let's plug in a 2.1. And if you look, you can see what's going on. We're getting closer and closer and closer to x is equal to 2. All right, so we're going to start at 4. Then we're going to go to 3, then 2.5, and then 2.1. With the vertical asymptote, y'all, you can't go through it. So it's either going to come toward the asymptote and bend upward, or it's going to come toward the asymptote and bend downward. All right. So we have to remember those rules from pre-calculus because they really will help us a lot, as we're working through these problems. Okay. Let me just make this a little better. So now let's look at it. If we were to plug a 4 in, 4 minus 3 is 1, and 4 minus 2 is 2. So that would give us 1/2. All right. If we were to plug a 3 in, 3 minus 3 would give you 0. 3 minus 2 would give you 1. 0 over 1, of course, is 0. If you were to plug a 2.5 in, 2.5 minus 3 would give you, and I'm going to show this one, a negative 0.5. And that would be divided by what? 2.5 minus 2, which will give you 0.5. So of course, this would simplify to a -1. And let me draw this out here. That would be a -1. And once again, if you put a 2.1 in, we're getting closer and closer and closer to 2. 2.1 minus 3, that will give you a negative 0.9. 2.1 minus 2, that would give you what? 0.1. -9 divided by -0.1, that will give you a -9, as we can see it. All right. So we're just working these problems out, and all we have to do now is plot the points and graph. So yeah, I'm going to draw these small points right here. So at 4, x is equal to 4. That's 1, 2, 3, 4. You have what about? You have about 1/2. Let me try something here. Well, at 4, it's about at 1/2. At 3, it's 0. At 2.5, I'm in the middle here. That would be -1. And at 2.1, which is very close, that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So at 2.1, that would be about -9. I'm going to come right here. And let's make that red, matter of fact. Yeah, let's try to draw this as perfectly as we can. And as you can see, it goes toward here and it bends downward. And I'm going to try to draw this. Guys, this is not all the way perfect, but I'm trying to get closer and closer and closer to that line. If you remember, the vertical asymptote is going to be 1. That's like another lesson, but yeah, this is what's happening. So in the end, what's happening is this is actually going towards -infinity. Why? Is because it's going lower and further down as you get closer and closer to that asymptote. Had it gone toward the vertical asymptote and gone upward, it will go to positive infinity. But in this case, it is -infinity. This is how our graph is going to look.